This is the Authority Partners podcast.
Hello, everybody. Today we have with us Steve Smith, and we are going to be discussing the topic of clean architecture. Steve Smith has been recognized as Microsoft MVP since, I think, 2002, like more than 20 years, and was a member of Microsoft's Regional Director Program for 10 years. Steve has published several courses on our site covering architectural topics like DDD, solid principles, design patterns, software architecture in general, and more. He is also a founding member of the ASP Insiders, which is an advisory group for the ASP.NET product team, and is a regular contributor to the product and authoring many sections on the official Microsoft documentation on GitHub. So, Steve, thank you very much for joining us to this podcast.
Thanks for having me on here, Mirano.
No problem, you're welcome. So, the first thing, clean architecture, what that really is. I mean, how is this approach different to other historical approaches in this area, and what is it that you can tell us about its main principles and key concepts?
Sure. So clean architecture is a variant or an evolution. Other similar architectural approaches, the ones people may have heard of are onion architecture, as well as ports and adapters or hexagonal architecture. And those have been around for a long time. I mean, onion architecture was introduced in 2009, ports and adapters, hexagonal, even earlier than that. So going on 20 plus years old. And the fundamental principle of these approaches is one of favoring abstractions instead of concrete dependencies on infrastructure concerns. And infrastructure would be things that are out of process from your computer, things that are separate from the logic of your application. So that would include the user interface, the keyboard, the mouse, the device that the user is using. That would include the file system. And of course, that would include things like databases and web services and web APIs and things like that.
Okay, great. Thank you very much. So my next question would be, and I hope this is going to have a broader audience, so I just want to cover that. So why would actually someone go about it? I mean, why would somebody go using it? Is it in your opinion, is it a better, more streamlined approach to tackle the general architectural, common architectural challenges, such as the ones that we have: maintainability, testability, scalability, so on, and also implementing kind of the clean code practices, or maybe or is it striving to cover all that together and to improve on it?
Sure. So, one part of your previous question I didn't really cover was how does it differ from other approaches? So I'll start with that. Clean architecture is basically all about the organization of the modules within a single application. So from an architectural level, it's basically only concerned with one application. And if you were building something with, say, a microservices architecture, you might have a dozen microservices. Each one of those microservices could be organized using clean architecture or not. And so that's kind of the level of where it operates, is at an individual application level. Other ways that folks typically design individual applications and their modules in the past have often used a so-called N-tier or N-layer approach, where you might have the user interface that talks to a business logic layer, and it talks to a data access layer, and then that talks to the database. And maybe you have similar utilities for web APIs and things like that you depend on. That approach gained a lot of traction, especially in the .NET world, but it results in code that is tightly coupled to those external concerns like the database. And that starts to be a problem if you decide that automated testing is something you really want to pursue, because if you want to write unit tests that don't have dependencies outside of your code, and there's a lot of reasons why you want to do that. They're a lot faster. They're a lot less brittle. They're a great way to increase confidence in your code base. It's very difficult to do that if you have a lot of dependencies on third-party, infrastructure concerns like databases. And with an N-tier approach, the dependencies are all transitive, right? So the data access layer depends on the database, but the business layer depends on the data access layer, and the UI depends on that. And so everything ends up depending on the database, which is great at production time. That's fine. I mean, you probably need the database in production. But if you want to verify that some business logic works all by itself and you don't care about the database in this case. You just care about, the inputs you give it and the outputs it provides back. Having that dependency on the database makes it really difficult to do that in a clean, maintainable, unit testable way. Another approach you might follow is to just not have any particular architecture or modularity in your system. You could just put everything in a single folder or a single module and have everything mixed together, right? In which case you'll have data access stuff sitting right next to business logic stuff. And that can result in kind of a spaghetti code approach where you don't even get the benefits of n-layer architecture, which are, separation of concerns. It's easier to know where things are and where they go, and you get code reuse, and maybe your teams can work independently on these different layers, right? You don't get any of those benefits, and you still have, depending on how you build it, this potential for having a lot of coupling and dependency on third-party concerns, databases, infrastructure, et cetera, et cetera. And so whether you have no real layers or separation and you just have everything in a folder, or this n-tier approach where the dependency flows toward the database, either one of those would lead you to this sort of pain area, the pit of despair, if you will, of having it really difficult for you to automate the testing of that system. And if you don't automate the testing, then it makes it difficult to refactor the system as well. And so the longer that system lives, and the more of a legacy system it becomes, the more difficult it is to maintain and change that system over time. This is exacerbated if you have shared databases, which many organizations do. This is sort of separate from clean architecture, but if you've got one application that talks to one database and it follows this n-tier approach, yes, it's going to be difficult to test because it's got all these dependencies on the database. But it's even worse if there are like 6 different applications that are all depending on that same database, because now even if you wanted to refactor how that one of those applications works and how its data might be structured, you can't, because all those other applications also depend on that database and its schema. So it makes it very difficult for you to make any breaking changes to the data store once you have a shared database between several applications. This is especially a common anti-pattern in microservices, where folks will try and build microservices, but they'll still share the database, and it's just not a good idea. So I think that answered most of the first question. I'm not sure I got to all of your second question, so I'll come back to you for a minute.
Sure. Okay, thank you very much. This was really kind of a good explanation. Thank you very much. So the second one was just like, why would someone use it? Is it like you believe that it's a better approach, in general, like a more streamlined approach tackling common architectural challenges such as maintainability, testability, scalability, and others, or also implementing the clean code practices, the ability to more easily implement clean code practices, or maybe all of that together?
Yeah, it helps with testability, like I already mentioned, because it makes it so your business layer, especially, which if you're following domain-driven design, that would be your domain model, it has no dependencies on any infrastructure. And so it's really easy to write unit tests for it. And unit tests run really quickly. You can run thousands of them per second. So it's where you want to put most of your logic as far as testing, the business logic of your system. So for maintainability, it's great. For testability, it's great. For scalability, it varies, right? It depends on your application and a host of other concerns. But like I mentioned, it's a common approach to building microservices, and microservices, one of their key potential benefits is scalability. And so it does yield scalability when you apply it with another architectural approach like microservices. Now, this approach, this clean architecture, or ports and adapters style, is very much dependent on, or at least works really well with object-oriented programming principles. Object-oriented programming principles are, there's a bunch of them, but a common set that are pretty well agreed on in the industry are the solid principles: single responsibility, open-close principle, interface segregation, list-cow substitution, and the dependency inversion principle. And the dependency inversion principle is really key to this whole architecture. You will naturally arrive at clean architecture if you just follow really just single responsibility and dependency inversion. Those two things, if you just refactor your code aggressively to follow those principles, you will end up at clean architecture. It follows naturally. And the reason for that is the dependency inversion principle basically says that your code, your application, your high-level modules, especially your business logic, should not depend on the concrete implementation details of how something works. So, for example, if you have some customer class, it shouldn't depend on the concrete details of how you get data, right? It shouldn't depend on some SQL data reader class. Instead, those high-level modules should depend on abstraction. So if we're talking about an object-oriented programming language, that means we're talking about interfaces or abstract base classes, typically. Then it goes on to say that your abstractions should not depend on details, but instead the details should depend on abstraction. And so an example of an abstraction depending on a detail would be, okay, I'm going to take that customer that depends on a SQL data reader. I'm going to refactor it. I'm going to have it use an interface, and that interface is going to return a SQL data reader. Like, no, that's not good, because now the interface still has that low-level detail in its contract. Right, you want to make sure that that is hidden away, or else your abstraction isn't really helping you. It's not really abstract, and so you would want to have your customer class depend on, let's say, some interface that returns back an enumerable or a list or something that does not bleed the details of how it's actually being implemented. And so if you follow that, what that means is that all of your low-level code for like reading a file, calling a web service, getting data from a database, all of those things are going to depend on abstractions that live in your business logic layer, in your domain model. And so that's the core of the application, is where that stuff lives. And you put all your infrastructure concerns into another project, which I typically name infrastructure. And so if you're building a .NET application and you're using Entity Framework, your DB context and your other services that use the DB context to get data, all of those would live in this infrastructure project, and they would depend on your core project, your domain model project, instead of the other way around. And that's where that dependency is inverted, and that's what lets you achieve all the benefits of clean architecture.
Okay, thank you very much. This is a lot of useful information, and glad we discussed it. So just something that really reminded me. So what would you say from your experience, where would be the most benefit of it? Like using it in the like a monolith backend, or using it in a newer like microservices approach where you have usually microservices, you are kind of trying to kind of limit the scope there around somewhere around the bounded context, right? So that would be the ideal, have one microservice per one bounded context. But where would you believe that it would yield more kind of benefits, like to the first monolith approach or to the microservice approach, or it doesn't matter?
I use it in both. I use it for monolith and I use it for microservice. Each individual microservice is deployed as a single application. You could argue that you could use the term monolith for it, right? That one microservice is a monolithic application. It's just a really small, thin one with a single, focus, a single bounded context. So whether you're deploying an ASP.NET Core application with all of the functionality, in it and no other, services that it works with that are out of process like microservices, you can use this clean architecture approach. And then if you are using microservices, then frequently it does make sense if they're complex enough to use this approach for them as well. Now, sometimes the microservices are so tiny that folks will just use serverless for them, and they'll use Azure Functions or Amazon Lambda or something as their implementation. If you're doing that and your microservice is that small, you probably don't need something like clean architecture to organize that code. But if it's bigger than that, if it's if you're building it with .NET and not as a serverless, something that you're going to deploy, then you may see a benefit in using this approach. Now, it does have a minimal amount of complexity, and that's why I say that if you're doing it, just as an Azure function or something, it's probably overkill. But it's not that much. Your minimum thing in a .NET application is going to be one project that yields one assembly. If you're going to follow the clean architecture approach, you're typically going to have 3 projects. You're going to have the one assembly that is your entry point. So that's your executable, your ASP.NET Core app, or your WinForms app, or whatever it might be. And you're going to have your domain model or your core project. That's the one that has no dependencies, has all your business logic, all your abstractions typically live there. And then you have one more project, which is your infrastructure project. And that basically has all your adapters that implement your abstractions and go communicate with out-of-process infrastructure concerns, databases, web services, whatever it might be. And so it's not this massive, huge thing that's hard to wrap your head around. It's just 3 projects. It's really small, and each one is really well focused on what it does.
Okay, so all of that provided in the microservices world, that you are using one database per microservice, right? No shared databases.
That's right. Yeah, if you're using shared databases with your microservices, you're building a distributed monolith, and that's just a world of pain.
Yeah. Okay, so going forward with this, so how do you set it up? So like on a practical side, I mean, if someone would decide to use it and they already understand the principles and the motivations, so they are kind of understand why would they go about it and what benefits it yields, how would you really go starting using it in your project? I mean, are there any, like at the operational level, are there any shortcuts that you can share with us, or maybe the best approaches that you would recommend having an extensive experience in this area?
Sure. So So first off, there's sample projects that are out there that you can look at that'll show you how this stuff works and kind of where everything goes. Microsoft has a reference application that I help maintain called eShop on Web. If you just Google that, it's going to be the first hit. It's hosted on GitHub. There's a free ebook that's about a 100-page PDF that goes with that I wrote that you can read to kind of further cement some of the concepts. But it kind of shows you how everything's laid out. It's got the three main projects. It has a few more projects because it also has a Blazor application in there too. But the web app just has the application core, the infrastructure, and the web project that I described. If you are starting from scratch and you're in the .NET world and you want to create a new project using Clean Architecture, then check out my Clean Architecture solution template, which you can install using the command line, and then you can create new projects saying .NET New Clean Arch, and it will create it for you. So that's on my GitHub. It's at github.com/ardalis, ARDALIS/Clean Architecture. Probably there'll be a link in the show notes, but you can also just Google it. And that's available as a NuGet package. And when you install it, it gives you this template that then you can create a whole solution from. One of the things that's always bugged me about the Microsoft project templates and Visual Studio templates is that they generally only have single project templates, or you can create a blank solution, but they don't have much in the way of solution templates where things are all put together for you the way they should be. And so that's why I created this one, because I was getting tired of doing it by hand. Now, if you're not in the .NET world, or if you are in .NET and you want to do it by hand yourself, then what you should do is basically you need to create those three projects. So what I typically do is I would start with the core project. So just open Visual Studio or drop down the command line, say .NET New, create this project, company name, .core, and in there is where you're going to put your business models, your entities, your value objects, your things like that, the high level conceptual parts of the system you're building. Now, you are probably going to want to store that data somewhere at runtime. So maybe you want to have some kind of an ORM that's going to connect to a database, or even just write the SQL queries yourself, or whatever it might be. So you're going to create another class library called infrastructure, or acme.project.infrastructure. And in there, you're going to add your DB context or whatever you're using for data access. If you're going to be talking to web services, you'll add, some services in there that use an HTTP client or what have you to talk to a service. Anything that talks out of process goes into that infrastructure project. And you're going to have that project depend on core and implement interfaces that are defined in core. So your interfaces should normally be put into that core library and then implemented in the infrastructure library. Now, we haven't even built the front end yet. So now the last thing to add is going to be your user interface project. And so that'll be, ASP.NET Core, or it could be WinForms, or it could be a console app, whatever it is. You're going to add that project now and have it have a reference to core. And also it will need a reference to infrastructure because it needs to use those types at runtime. It is possible to set all this up without that project reference and instead just copy the DLL from the infrastructure's bin folder into the UI project's bin folder and then load that up with reflection. And some teams do that as a way to make sure that team members aren't using those infrastructure classes directly inside the UI project, except for, at the composition root where they're wiring up to dependencies. But most of the time, you just add the references. And then you just use some discipline to make sure that you're not just newing those things up anywhere in the UI project. You should just be using them inside program.cs or startup.cs when you wire up the dependencies for the system. Does that make sense? And of course, if you're doing it in Java or Rust or some other system, it would be pretty much the same. The only difference is going to be that you're going to be building this with the modules of that system. So they won't necessarily be projects or assemblies like they are in .NET. They'll be jar files or whatever in a different platform.
Yeah, okay. That was nice actually, because I for the last year or so I'm hung up on doing Rust. I really love it. So coming back to C++ world that I really enjoyed 20 years or something more. But it's I didn't know that you can actually do this approach. But probably a similar approach could be employed there with the Rust as well. Rust seems to be really getting a traction, because if I see the Stack Overflow and other sites over there, that it has generated a lot of interest over there. But in any case, thank you very much for responding to this this because it's really important for people to understand. And you gave a lot of pointers on how to really start with implementing a clean architecture approach if they were to start with it. So a lot of good kind of ideas. So thank you. And the last one question, in your opinion, what would be the trade-offs and main disadvantages of using it? Because, I mean, we can safely assume there is no such thing as a free lunch, right? So what would be the main disadvantages and trade-offs, in your opinion, when implementing the clean architecture?
Sure. So clean architecture depends heavily on abstractions. I mentioned that, in the .NET version of it, you're going to have interfaces as your main abstraction tool, and those are going to live in the core project. When you're looking at this system, if you're not used to working with interfaces and abstractions, and you're used to being able to just kind of follow the flow of the program by saying go to definition, and you immediately see exactly the class and exactly the method that's going to follow, initially it may throw you off because when you're dealing with interfaces everywhere, if you say go to definition, you're just looking at the interface. You're not looking at the actual code that's going to run. And so you need to kind of change your habits a little bit. And the tooling has evolved. So, Visual Studio has another menu option you can pick, which is go to implementation. And that's the one that you'll kind of build muscle memory of using all the time, because that's what you really want to follow to see what's actually going to be the code that's going to run at runtime. You're going to end up with more files typically when you follow this approach. Even if you just follow the solid principles in general, you're going to end up with more files because you're following single responsibility principle, because you're following dependency inversion. So you've got now interfaces as well as concrete classes. Because you're following interface segregation, those interfaces are going to be pretty small. So you're going to have, instead of one giant interface and one giant class that does it all, you're going to have half a dozen smaller classes and half a dozen interfaces to go with them. And the net result is that there's more files to navigate in your solution than there would have been if you just had everything in one project with, really big classes. And so you have to develop better skills. If you don't have them, you have to just practice being able to navigate that type of solution quickly. So if you're used to just a few files and you really, your one finger is really big from using the scroll wheel all the time and building up that muscle, right? You're probably not going to be scrolling quite as much as you used to. Instead, you're going to be using other tools to navigate around. My favorite tool, if you're using Visual Studio, is Control T, which is the super search that will let you search for a type, a file, a method by name. And then the other trick that goes with that is you can find any of those things just by typing the first capital letters that are in it. So if you have some, order completion checkout service, right? So it's like OCCS. So you say Control T and then you hit capital OCCS, then your order completion checkout service will be the first thing that pops up probably, unless you have a lot of things that have OCCS capital letters in them. And so it makes it really quick to be able to jump around inside your code, even if it's spread out between 3 projects and it's spread out between hundreds of small files. But that's the biggest trade-off, I think. The other one is there is some performance overhead of using these abstractions. It's generally pretty minimal compared to other object-oriented techniques, but it could be significant compared to functional programming techniques. And there's been a recent debate in the industry about this that folks may have seen. So, if you're using object-oriented programming anyway, and you're using C# and .NET anyway, you're not really paying a huge price for using this indirection in your code. In fact, it's sort of the right way to do object-oriented programming, in my opinion. But that does not optimize necessarily for performance. So that can be a consideration as well, and one that in some cases you'll need to optimize for individually. Like if you see that this particular path is being too slow, then you may want to optimize it. The types of software that most businesses are writing that are very much data dependent. Generally, the trips to the database dwarf any micro optimization of performance you might make at the C# level for how you call a method, right? Whether calling a method directly takes a microsecond or you call it through an interface and it takes 10 microseconds. When you go to hit the database and that's a 30 millisecond jump, that dwarfs the microsecond numbers. So they tend not to matter.
Okay, nice explanation. So, I guess we have rounded this approach to clean architecture pretty well. Thank you very much for being part of this podcast about clean architecture and a very interesting and advanced approach to solve common architectural challenges, and hope to catch you again.
Great. Always a pleasure, Mirano. Thanks.
Okay, thank you. Have a nice day.
Thank you for listening to Authority Partners podcast. Stay tuned for the next episode.